When we're looking at hydration, we're using H2O and H+, and the same rules are followed here as was followed when we were looking at the hydrohalogenation. So the H+ will add to the double bond, the plus will end up on the most substituted carbon, and the H will end up on the other side of the double bond. So the H goes here, the plus goes here. This is where the water will come into attack. The water comes into attack, loses its H+, and remember that the arrow will always go from the bond and to the oxygen. And remember what we're showing there is the 2 electrons in that bond going onto the oxygen so that the positive charge can be satisfied. This leaves the hydrogen here with an H+, and the OH ends up being attached to the most substituted carbon of the double bond. So this is the same kind of thing as we were looking at with the hydrohalogenation. Markovnikov's rule still holds. Another way of doing this is to use mercury acetate and hydrogen peroxide. I didn't really want to go through the mechanism for this one, but let's suffice to say it does follow Markovnikov's rule, and what happens is the OH ends up on the most substituted carbon of the double bond. So again, we look at the double bond and we see how many carbons are attached to each carbon from the double bond. This one has 1, 2 attached to this carbon, and this one has 1 carbon attached to this carbon of the double bond. So this carbon is the most substituted carbon of the double bond, and that's where the OH ends up.